Okay guys, I'm just gonna start. I don't think anyone else is coming, but so today's lecture is about file inclusion and path traversal. They're not very difficult vulnerabilities to understand, but there's a lot of content in them, so I would try to get through most of it today, but there is a lot more out there that is outside the scope of this lecture. So before I get into the vulnerability itself, I want to give you a brief overview of the client-server model. So if you remember from the introduction to the web lecture last term, we briefly touched upon the client-server model. So we have a user who interacts with a browser, which is the front end, and that will be the client in this model. And then that interacts with the server, which is the back end. And in the web, all of these requests and responses are HTTP requests. So very simple recap of what we learned last term. And the reason why this is important is because we're going to focus on this section, which is the communication between the server backend and the files that live on the server. So I got this diagram from TryHackMe. I really like it because it gives you a really clear separation of which services are responsible for all the requests and responses between the front end and the back end. And the vulnerabilities that we're going to talk about today focus specifically on this section, which is the server-side scripts accessing the file system. For example, if you want to load images, logs, text, or app configurations. Okay, so brief introduction to server-side scripts. So last term we focused mainly on the client side, mainly the JavaScript that runs on your browser. But unlike client-side scripts, server-side scripts live on the server, which hosts the web application. And crucially, this means that those scripts actually have access to the server's file system and database. A lot of server-side scripts are written in languages like PHP, Python, and JavaScript. So you might have heard of some of the frameworks here, like Laravel, Django, and Node.js. Poorly written code in these server-side scripts are what really lead to file inclusion and path traversal vulnerabilities. But for this lecture, I've just focused on PHP scripts because that's the most common one. Okay, so this is sort of like a new format. I've decided for each vulnerability I'm going to write a profile to just give you a sense of what it is and how it works. So what is it? It's a web security vulnerability. It allows an attacker to read files which is outside the operating system. It allows the attacker to read operating system resources which is outside of the local web application. So if I have a web application that lives in a certain folder, this vulnerability will allow me to read things outside of it, for example, a root folder or system files. And how is it done? It's done by manipulating or abusing the web application's URL to access files or directories stored outside the application's root directory. So in PHP, path traversal vulnerabilities occur through functions like file get contents. This function is mainly used to display the contents of a file in a web application. But of course, if a developer uses this function but then passes user input directly into the API call without any input validation or filtering, it actually allows an attacker to use a traversal string. So you might recognize the 2 dots and a slash, which correspond in Linux to moving up one directory. The same can be applied to passing this string into the file get contents function and allows you to navigate up directories on the server. So we'll go through and look at an example now. Let's say I have a website and I have a get.php file. And all this get.php file does is I can fetch a file. And in this case, the intended use case is I want to see my CV. So the web server will read the file parameter, which is resume.pdf, and typically it will show me the contents of that file. So here's the function structure of file get contents. But what you can see here possibly is that an attacker could perform path traversal if they modify the value of file name passed to this function. So here's the example of a very simple path traversal attack. What I'm doing is I am going up few directories to try and read the etc password file. So the script expects me to read a file in the CVs directory, which is where my resume lives, and it's located inside var www.html in the web application directory. But if you see the payload that the attacker is sending to the web server, what it does is it's traversing up the folders until it reaches the root, and then it goes down to the etc and password file. Now the payload will request the server-side script. It will go up, and then because there's no input validation in the file get contents function, the web server accepts that as a perfectly acceptable file to show the contents of. So you will get this back in the website because it doesn't know how to distinguish from what would be a valid and invalid file. So even though this file is far outside the scope of the initial web application folder, it's still a valid file in Linux, so it will display all of the contents, and the function won't return any errors. So file inclusion is very similar, yeah.
Can I just ask a question on the path traversal? I know in really old servers, you could literally even do the path traversal not as like a get around, but in your base URL itself, http:/get.php, maybe then /. etc. Have you ever come across, like I'm talking about like 1990s web servers?
Yeah.
Have you ever come across that in any vulnerability? Is it principally only in a get around and maybe post around or something?
That usually depends on, I guess, if you say the 90s, I wouldn't really know how the implementation of...
IIS
Yeah.
1.2, and it's 1997.
Oh, okay.
In other words, I think it's been patched on almost everything.
Potentially. So the content that I'm teaching now is around about PHP 4, 5, 6, 7. So it is between like 10 years ago and now. So it's still applicable, but obviously what's changed is PHP applications they tend to use GET requests now for fetching files even within its own system. So that's the reason why we have to use a parameter here. So this one saying file equals your payload, because essentially in the PHP script you would say get the variable _file, and that would be asking the PHP script to fetch the file, well, the value of the file parameter that you pass in as a file. Does that make sense?
Right.
Okay. We'll go more into this because there is a bit on the absolute and relative pathing that I do want to talk about. Okay. File inclusion is very similar vulnerability, but there is a key distinction between path traversal, and that is it allows an attacker to read, modify, and execute files on the server through inclusion. So whereas in path traversal you can just display and read the contents of a file, this one is even more dangerous because you can potentially execute certain pieces of or certain contents of files on the web server by simply loading it through inclusion. And how is it done? Same thing, you manipulate and abuse the web application's URL to load files into the current page, displaying or executing the contents of the file. So this time the functions that we have to be careful of is the include once and require once functions. Essentially in PHP, these functions allow you to get the page of a file and then load it into your context of where the script is. Same thing, if there's no input validation or filtering, the attacker can still use traversal string to navigate outside of the folder of the web application. Okay. And there's two different types of file inclusion. There's a local file inclusion and a remote file inclusion. So we will go into the local one first, and then we'll talk about the remote one after. So what are the risks of file inclusion? An attacker can use file inclusion vulnerabilities to do the following. So first thing, they can leak sensitive data. So if your code is proprietary and you are you have file inclusion vulnerability on your application, someone could leak all the source code. They can get the credentials, they can get databases, they can get, configuration keys, environment variables, things like that. So essentially, you are given sort of file access on the web server. If the attacker can also write files to the server, so essentially if you have a way of injecting code into the server files, if you use file inclusion, you can even gain remote command execution. So we will talk a bit more about this later, but if you have the ability to inject code into a web server and then include the file with the code through inclusion, you can actually execute the code that you have injected into that file. So the first type of file inclusion is local file inclusion. And we'll give you a bit of context as to how the include function is used in the first place. So let's say I have a website and I have an index PHP, so that's like my home page, and I have a parameter called lang. So if I look at the file structure of my web application, which is an app, I've got 3 different files. And this is useful because in a typical use case, I could provide, say, my homepage in 3 different languages, in English, French, and Arabic. And all I have to do is really change the value of my lang parameter, and it will load the corresponding translation into my homepage. So the PHP code uses the GET request via the URL to include the file of the page corresponding to the language that I requested. And that GET request will look like this. Make sense? Okay. Now, if, let's say, there is no input sanitization or filtering at all, and the user input is directly passed into the include function, the user can actually request any kind of file using the lang parameter. So if you put /etc/password into the include function directly, it will include that file into the page, the PHP page. Okay, so you have a question?
How is it possible for the file that you include, that you pass it to include, to not be valid PHP, such as that's not valid PHP, the password file? Because surely include executes the contents of, say, the en.php or whatever.
So the PHP include file is a bit more flexible than that. The include function is more flexible because sometimes it's not just PHP files that you want to display.
So just need to render it onto the page.
Yeah. So if you think about the get file contents function we had earlier, if it isn't a PHP file and it's not run by the PHP engine, then it would just be the same functionality as get file contents. So let's say it was a text file with I don't know, it could be like some numbers or some text that tells you description of my website or something like that.
So it's not like, say, C++ hash include, where the thing you're doing has to be a valid source code for the compiler.
No.
This is just dump it onto the web page.
Yeah.
But if it is valid PHP with PHP function calls, etc. inside it, then those will be executed.
Yes.
Yeah.
So,
Because
yeah, if it's not even just if the whole file is a valid PHP. If there's some valid PHP, like the PHP, the tags, yeah. If that even exists in a text file or any random other file, it will also execute that because it's kind of like it's reading the lines one by one. If it's executable, it will just run the line. Make sense? Okay. So here are 6 local file inclusion cases. This is the reason why it's quite a big, even though it's not necessarily a very difficult vulnerability to understand. There are a lot of techniques that attackers can use to sort of gain a privilege escalation on the server as well. So we'll go through all the cases. They start quite simple, and then there are some at the end where you can gain some remote command execution. Alright, so the first one is include specified directory. So let's say the developer wants to do a little bit of input validation, and they say, well, let me include the languages folder into, I shouldn't say include, that's like kind of tripping me off. Let's say they put the languages folder as a requirement for the include function. This means that the files that will be put in the include function, they are expected to come from the languages folder, and you wouldn't be able to get files outside of that folder. But how can the attacker perform local file inclusion? So it's the same premise as path traversal, because this time you are in the languages folder, you can use a traversal string to get out of that folder. So you can see here, it's the same payload as what I showed earlier in path traversal. You put the path traversal string, so it's like // you move up the directories, and then you can go and find the files that you want. So instead of using absolute pathing to include system files, you use something called relative pathing, which is what I showed earlier in the path traversal. Okay. So now let's say we're doing some black box testing, and I enter this exact same payload as the scenario just now, but I get this warning. It says here, include languages etc password failed. So you might see a clue here is that in the warning compared to my payload, you can see all of the // have been stripped out. So one of the clues you can get from the error message is that you can kind of guess the implementation that the developer has done for some input sanitization. So what we can see here is that most likely what the developer did is in the include function, check for any of those traversal strings and then strip them out before passing it to the include function. Does that make sense? So how would an attacker sort of like bypass this? We can use something called obfuscation. So it's kind of similar to a different topic that we did before, but essentially what you see up here is that rather than using just the dots and the slashes in the expected pattern, you can put more dots and slashes between them, and because the filter only removes the substring in one pass, you get the same payload as before after removing after the filter removes the substrings. And that's one of the ways that you can bypass this kind of filter. A second way to bypass like a string filter is using encoding. So this is very similar to using URL encoding to kind of bypass string filters. This time I put the source code here that you can see. I think you might be able to just kind of get the gist of what it's doing based on the PHP code. So essentially what it says here is it's trying to get the page parameter. If it contains the // string, it rejects it outright. And also, it must contain the var www HTML directory. So in this way, the developer is is kind of on the thinking that, well, if I force the user to include the folder, there's no way that they would be able to escape it. And so we can use URL encodings. So obviously, if you remember this payload, you put it into the URL bar on your browser. If you use the encodings, they are passed into the web server, but obviously they are decoded after the filter. So the filter will still see the encoded version of the string, and you can actually use that to bypass the filter that I showed earlier. Okay, now we're on more advanced techniques. So this one, there are several ways to write to files on the web server, and PHP sessions is actually one of them. So if you see on the code that I have on the slides, it shows you that it stores the value of the page parameter in your session. And because session data is stored on the server side, they exist as files on the web server. Now, if an attacker can actually change the parameter and be able to save that value into a session file, by using file inclusion, they can actually run or execute whatever they put in that value for session. So let me explain. Let's say you are trying to use PHP session, right? This website saves your session as I showed in the code earlier, and you pass in this payload. So what it does here is that the attacker will first save the payload in the page parameter in their session data, and what that does is that it writes that value into a session file on the web server. Does that kind of make sense? So if you think about a normal application, it could be like, you log into your bank or something like that. Your session will contain certain information about you. It could be your name, it could be your balance, things like that. So those get saved into your session file, and you have a session ID that is stored as a cookie in your browser. That cookie is used to read the session file when it's being passed as requests to the PHP web server, and that's how it manages to get your session data. So if you go back to the code over here, if you see the $_session page, what that is doing is it expects the session ID in your cookie when you make a request, and it looks for the value of any page parameter that has been saved to the session file. Does that make a bit of sense?
It's just a built-in mechanism.
Yeah.
And what are the session IDs? Is it like an incremental number? 1, 2, 3, or is it like a long hash?
You'll see the format of the session ID in the next slide. So after they save this payload in their session files, what they can do is, so you can see here the session IDs they're just like random string. I don't really know the algorithm that's used to generate the IDs. I'm not sure if they're true. Yeah, I think that it is. But essentially, because so this kind of attack, you kind of also need a bit of background knowledge of how the sessions are saved in PHP as well. But because, say, the attacker does know, and it's saved under the session file with their ID in sessions, the web server will read they will actually execute the payload that was saved in the session file, and that's actually what you get. So the PHP info command that I showed you earlier over here, it gives you this kind of like visual display. It just gives you a list of like configuration information about the PHP web server, and this is actually, it's a bit like the alert function that we use in JavaScript to test cross-site scripting. It's not necessarily harmful, but it like very clearly proves that you can do remote command execution. Okay, so the second technique is we can use something called log poisoning. Log poisoning is a technique where an attacker will inject executable code into a web server's log file. So if you think about how we did it with the session file earlier, this time if we can sort of write or inject code into a log file, then include the file using file inclusion, we can perform the same attack to gain remote command execution. Yeah. So you see here, because the web server is using Apache, which is in the example that I've included, it writes to something called access.log. It is slightly different depending on which web server you choose to use, so like HTTPD or something like that. But generally, there's always there's always a log that's saved in like /var/log. So how do we poison the log? So one of the ways that you can do this is using netcat. Netcat will essentially allow you to. I made a mistake. There shouldn't be a dot. Yeah, there shouldn't be a dot there. I will correct it later. But essentially, it sends a request to port 80 of that IP address, which is the web server, and then after you press enter, it will let you sort of send a request. So usually what it expects is like a GET request or POST request, a valid HTTP request. But what I can do is actually send that string in. And when I enter that string, what will actually show up is, well, I'll get first a bad request, that is not a valid HTTP request at all. But in the logs, it will actually show up with that string that I've actually entered. And that's where you can see the entry point of the file inclusion attack. So now that I know that access log has the code that I injected just by using netcat, what I can do is go back to my, I think I put page twice, my bad. But essentially, I would include the log file in my page parameter. And what that will do is you will first see all the contents of the log file being displayed, and then at the point where it reaches PHP info, then you'll see it actually executes the code and you get a visual display of the information again. Okay, so this one is the last technique that you can use to gain remote command execution. It's called PHP wrappers. PHP wrappers it's like a function to manipulate data streams. So like it's used for on-the-fly transformations. And I'll show you a few more examples of what PHP wrappers there are. So the one that's most commonly used in this attack is the PHP filter. So you can see the filter, what it does here is that it takes a resource at the end, which is the password file, and what it does is it converts it to base64 using that filter, and what you actually get out is a base64 encoded version of that file. And if you decode this string using base64 decode, you will actually get some of the contents of the password file. So here are a few examples of filters that can be used. So there are string filters. For example, like we've got ROT13, it just translates the characters by 13 spaces. It's like a cipher thing. You've got two upper, two lower, so capitalize, lowercase. You've got conversion filters, so you can go between base64 and plain text, and you also have some compression filters. And I'll show you how one of these filters would be used in an LFI attack. So the first thing here is that the attacker can use the PHP code I've shown here as payload. And then what they can do is encode that payload to base64. When the server first processes the request, it will decode the base64 string, and then it will execute the PHP code. And that allows the attacker to run commands with the command parameter. So this might look a bit confusing, but by using the filter, it can actually trick the server into thinking that the payload you sent is a file that exists on the server. And essentially this is what happens, right? So I send that payload on the web server gets the base64 string, it decodes it, and then what it reads is the payload that was shown earlier, which is the system get command. And if you append at the end a second parameter, which is the command equals to hostname, so what I'm trying to do here is I'm going to run the hostname command with the PHP code that I just sent through the earlier part of the payload. What it does is that it runs the hostname command on the server, and you actually get the hostname of the server. Now obviously if you use it with other types of code, it would be potentially dangerous, because then you can gain access to the host server. Okay, so the second part would be remote file inclusion. In remote file inclusion, the attack is very similar to local file inclusion, but it allows an attacker to include remote files. Now this is slightly less common because it actually depends on certain options being enabled. So for example, in PHP, you need the allow _URL fopen option to be enabled in order to do this type of attack. So let's say the attacker goes back to the index page, and then they're going to try a file inclusion attack again, but this time instead of using a local file like etc password, they're going to try and load a text file from their own web server. So the web server gets the URL. What the web server will do is it will send a GET request to hacker.com command txt, and the attacker's web server will send that file to the web server, and the results of the execution will be sent back to the attacker. So this is really dangerous because if you think about it, if the payload in the file could be as big as the attacker wants, they could use it to potentially do denial of service. They could put in malware in there. They can use it to copy source code. They can perform cross-site scripting. So yeah, I would say that remote file inclusion, if the attack is possible, it would be even more dangerous than just local file inclusion. Okay, this is another diagram from TryHackMe. I quite like how clearly it explains, so it shows you the steps between the remote and local file inclusion. So you can see that the local file inclusion, it doesn't talk to any external server, it just accesses the files on the local system. Okay, so now we can talk about remediation. So how do we prevent these kind of attacks if you're a developer, developing a web app? Like, what steps can you take to prevent file inclusion and path traversal vulnerabilities? So the first one is obviously never try to pass in user input directly into API functions unless it's strictly necessary. And if you do, obviously there are plenty of input sanitization libraries out there that you can use. And I think there was a very similar concept when we learned about cross-site scripting. So we have the DOM Purify library that allows you to strip out any of the dangerous JavaScript before passing user input into a function. So that was for the client side, and obviously on this side it's for the server. So yeah, I said use user input sanitization libraries. Disable insecure options like allow URL fopen. Disable debug or developer environments. So this is the thing, like debug equals to true on things like Django. When you are in like a developer environment, you tend to have very verbose error messages, and those messages, like earlier, if you do a bit of black box testing, you can actually find clues and guess the implementation of the functions like include and get file contents, and that would also be a pathway for an attacker to gain file inclusion. And the last one is to use a web application firewall. So these firewalls, they kind of exist as like Docker containers as well. They have predetermined filters, so they are filters that experts have written for all different types of requests, and they kind of sit in front of your web application, and they will filter out the traffic that goes to your application. Okay, so in summary, we learned about file inclusion and path traversal vulnerabilities. They allow attackers to access files outside of the web application folder. And the vulnerabilities happen due to poor coding practices, so like a lack of input validation and filtering. We discussed several techniques that attackers can use to try and bypass those weak forms of input validation. So we've also shown how file inclusion can be combined with other techniques, such as log poisoning and session files, to gain remote command execution. And we also discussed some of the remediations that you can do. I got all of this content from the 2 TryHackMe rooms in there. They're very nice because if you do have TryHackMe, it's really useful to try doing the file inclusion attacks yourself to kind of learn how they function. There are also challenges in the rooms that allow you to kind of combine techniques in your own understanding to kind of get the contents of a file or retrieve a flag. And I think if you have TryHackMe, it's a really good way to learn as well. But we will do something similar in the workshop on Thursday. And yeah, I think that's the end of the lecture.